another Leetcode problem. 581, shortest unsorted continuous subarray. Yeah, so this is a medium question. And we are giving an array nums. So in such nums, there will be like random numbers. We need to return the shortest the subarray. So the subarray should meet the conditions. Yeah. So we need to find one continuous subarray such that if you only sort this subarray in non-decreasing order, then the whole array will be sorted in non-decreasing order. Yeah. So this means we need, for example, for the first example, we have 2, 6 until 15. We need to find a such continuous subarray like from 6 to 9. So we need to sort this array in ascending order. After sort this array in ascending order, then the whole array will be sorted in ascending order. So we need to find the shortest such arrays. Yeah. So if the shortest, you might think if it is not 5, you might think maybe it is maybe it is 6 from here, from 2 to 9. But that is not right, because we can even take 2 out. Yeah, because 2 to 15 is already sorted in ascending order, but inside they are not sorted. So after sorting, this shortest continuous subarray from 6 to 9, and then the whole array will be sorted. Yeah. So how can we solve this problem? Let me explain it in an example. So for this array, we have like 2 to 15. Yeah. So if this array is sorted, yeah, if we have another array, just if it is sorted, it is for 6, 8, 9, and 10. And for the last one, it is 15. Yeah. We can compare the first one, it is the same. And for the last one, from the right to the left side, it is also the same. But in between, 6 is not equal to 4, and this 9 is not equal to 10. So this means in between these areas is the shortest continuous subarray, because we cannot find a shorter than this. Maybe we can find a shorter, maybe it is 4, but it is not correct. Because if it is 4, this 6 is not equal to this 4. It should be the same. So it cannot be 4. It must be at least 5 from 6 to 9. Yeah. So we can solve this problem. First, we're gonna sort this nums array. After sorting, so first we're gonna sort. Yeah, we're gonna sort the array. So this is the sort. So after sorting, we're gonna compare from the left prefix and suffix. So we're gonna compare the prefix from left to right, and then compare the suffix from right to left. Yeah. So the second step is just to compare. Yeah. After compare, we got a pointer like left pointer and I pointer. So for example, for the first one, it is the same, and then the L pointer goes to 6. It's not the same, and then we're gonna stop the loop. And similarly for the right, from beginning it is at 15, but at 9 it's not the same, because this is 9, and here after sorted array it is 10. So this is the R pointer. So if this L pointer is less than R pointer, so the shortest length should be R minus L plus 1. Yeah. So it must meet the condition the L should less than or equal to R. Yeah. If the L, for example, we have an array of 1, 2, 3, and 4. Yeah. So the L pointer can always be shifted to the right side, and the R pointer can always be shifted to the left side. So this means L minus R is less than 0. If it is like that, it means the array has already been sorted. So we just need to return a 0. Yeah. So this is everything about this question. Now let's go to the code editor to finish the coding. So first of all, we're gonna sort the array. So I'm gonna prepare a variable called sorted nums. So inside it's gonna be sorted of the nums, and then I'm gonna prepare a variable n. It should be the length of nums. Now I'm going to compare from the left side and then from the right side. So first from the left side. So I'm gonna use a L pointer. So start as 0. Now I'm going to start from the left to the right side. So while L less than n, I'm gonna check. So if nums L not equal to sorted nums, not equal to sorted nums L, so I'm gonna break. So otherwise L should plus equal to 1. And similarly for the R pointer will start as n minus 1, and while R more than and equal to 0, and I'm gonna check if nums are not equal to sorted nums, R I'm gonna break. Otherwise, the R pointer would be minus 1. And finally, I can return R minus L plus 1. But it must meet the condition. It must be more than or equal to 0. So if R minus L plus 1 more than and equal to 0, else, actually I don't need to more than or equal to 0. I just need to give a more than 0. It should be the same. So if it is more than 0, I'm going to return R minus L plus 1 because it is a positive number. It is the shortest, it is the shortest subarray. Otherwise, if it is a negative number, I'm sure it has already been sorted like 1, 2, 3, and 4. I'm going to return a 0. Now let me run it to check if it works. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. As you can see, it can pass all the testing cases. And now let's analyze the time complexity. And the value of nums length is 10 to the power of 4, and we only used one sort. And this is just O(n), but for the sorting, it is n log n. So the time complexity is n log n, and the space complexity is O1 because we didn't use any extra memory. Thank you for watching. See you next time.